Alright guys, hopefully you had a good test. Now we're going to start a new unit, which is Unit 8, the last unit. So almost down the home stretch here. So with this, the first thing we talk about is solving a linear system, and then we'll get into matrices later on. So we're going to solve a system of linear equations using substitution, or we're going to solve the system using elimination. So any collection of two or more linear equations is called a system of linear equations. So x plus y equals 14 is one equation. X minus y equals 4. It's called a system because there's two or more linear equations. Solution set of a system of two linear equations is a set of all ordered pairs that satisfy both equations of the system. So by definition, a system of two linear equations and two variables with at least one solution is called consistent. No solutions is called inconsistent. And then whenever you have a consistent system, if it has infinite solutions, it's called dependent. Otherwise, it's called independent. So it says solve each system equation using substitution. So we're going to use substitution here. So what you do on substitution is you got to get one of the letters on one of the equations to say y equals or x equals. So if you notice this top equation, how it's got a single y, that's what I'm going to solve for. So I'm going to take 2x plus y equals 5, and I'm going to solve for y. So I'm going to subtract 2x to the other side. I'm going to say y equals 5 minus 2x. So now you're going to take this and you're going to sub it in for the y in the other equation. So I'm going to say 3x minus 2 times 5 minus 2x equals 4. So 3x minus 10 plus 4x equals 4. So then I'm going to add 10. 7x equals 14. I'm going to divide by 7. X equals 2. So now that I have x, I'm going to take that, I'm going to plug it in for my equation that I rewrote for y. I'm going to say y equals 5 minus 2 times 2, because I know what x is instead of 2x. So 5 minus 4, y is equal to 1. So your answer as an ordered pair is x first, y second, 2, 1. This is called a consistent system because it has at least an answer, and it's called, if you scroll back up to the top, you see how it says dependence, infinitely many solutions, so that means this is called an independent one. So consistent, independent means it has specifically one answer. All right, so then this one it says solve using substitution. Again, you probably want to find the one that has a single y, and we're going to rewrite it and solve for y. So this time I'm going to add the y over, and then I'm going to subtract 5. So 3x minus 5 equals y. Now we're going to take that, and we're going to sub it in for the y in the other equation. You notice when you combine like terms, after I multiplied and distributed, my 6x's cancel, so then I get 10 equals 10. Well, that's a true statement, so this is called infinitely many solutions. So if you get it to where it's like 10 equals 10, 2 equals 2, whatever it is, all right, it's called a consistent dependent. And your answer is actually infinitely many solutions. If I would have got like 0 equals 10, or 0 equals 5, whatever, okay, something like that, a false statement, it's inconsistent and there's no solution. So normally I would do a little quadrant partner thing here. It would do substitution. So this is where I would encourage you to try these by yourself, just as a practice. to the first one, you should have got negative 3, 2. And this one's going to end up being a false statement, so this one I kind of want to talk about. So my x's cancel, so I get 14 equals 10, which is not a true statement, so it's no solution. So now you've seen one of all the types. So if it's a true statement, right, it'll say 10 equals 10 or whatever, they equal the same number, which will give you infinitely many solutions. If it's a false statement, then it's going to be no solution. Okay? Now elimination. What you do on elimination is you want one of the x's or the y's to be the same number and one to be positive, one to be negative, and then you just add the equations together. So if you look at this, my y's, one's positive, one's negative, and they're the same number. So I'm going to add the equations together. I'm going to get 8x equals 12. I'm going to divide by 8. X equals 3 halves. Because the y's would cancel. So now I know what x is, so 3 times 3 halves. We're going to plug it in. So 9 halves plus 2y equals 4. Subtract 9 halves. 2y equals negative 1 half. Divide by 2. Y is negative 1/4. All right, elimination if you do not have a number that's the same. However, you notice my y is a negative 3y, and this y is a positive y. Well, I can change the whole equation by multiplying the whole thing by 3. So now we get 2x minus 3y equals negative 7. The top equation doesn't change. The bottom equation is going to become 9x plus 3y equals negative 15. Now I can add the equations together. I get 11x equals negative 22. Divide by 11. X is negative 2. So then you can plug it back into the original equation. 3 times negative 2 plus y equals negative 5. And it doesn't matter which one you plug it into. So you should have got negative 2, 1 on that one. So quadrant partners, this is elimination. I want you to try elimination on these two. I would pause the video right here, attempt them, see if you can get them right. So you should have got 13 over 3, negative 4/3, and the other one's no solution. Because whenever you get it to where they're the same, they do not equal the same number. Okay, the last thing you're going to see is a system in 3 variables. All right. Now this one, it's kind of up to you on how you want to solve it. I usually like to just stick with one method, but you can do whatever you want here. You can use elimination or substitution. I would say this one's set up for elimination. So what you're going to do is we're just going to look at the first 2 equations. So if I'm going to eliminate, let's say I want to get rid of the y's. All right, so I need to multiply the top equation by 2. So 2x minus 2y minus 4z equals negative 12. The bottom equation doesn't have a z, and that's fine. So now we're going to add the equations together. So I'm going to get 5x minus 4z equals negative 37. So now you did with the first and the second. So now you have to do the first and the third or the second and the third. It does not matter. I'm going to do the first and the third equation. I'm going to add those and get rid of my y's again. But you have to eliminate the same variable. So you see how we eliminated the y's in the first pair? That's what we're going to do in the second pair. So I'm going to add those. I'm going to get negative 3x minus 3z equals 6. So now I have 2 equations. Negative 3x minus 3z equals 6. 5x minus 4z equals negative 37. They're set up for elimination or substitution, kind of however you want to do it. I'm going to do elimination, so I'm going to multiply the top equation by 5, the bottom equation by 3. So I'm going to get negative 15x minus 15z equals 30. 15x minus 12z equals, I need to grab a calculator, 37 times 3 is negative 111. So my x's cancel, so then I get negative 27z equals negative 81. Divide by negative 27. Z is 3. So we got z, now we got to find x and y. So what you can do is you can take the z and you can plug it into either equation that we rewrote when we did the first set of eliminations. So I'm going to say negative 3x minus 3 times 3 equals 6. Negative 3x minus 9 equals 6. I'm going to add 9. Divide by negative 3. X is negative 5. So now that you have an x and a z, you can plug it in to any equation that you started with, so one of these three, and solve for y. I'm going to plug it into the middle one because I know what x is. So I'm going to say 3 times negative 5 plus 2y equals negative 25. So negative 15 plus 2y equals negative 25. Add 15. 2y equals negative 10. Divide by 2. Y is negative 5. So you should have got negative 5, 3. All right, so when you do that, it's kind of up to you on how you want to go from there. On the next one, you can use substitution or elimination again, but I would pause the video here and try it. And then the answer will be posted on Google Classroom with the notes. All right? And that's pretty much what it is. There's a paper assignment with this one, so if you guys have any questions, please let me know. Otherwise, that's all it is, solving a system. Have a good day, guys.